Hello everyone, this is my second video. Just a quick little over sketch here on what we've done. We talked about the last introduction. I changed the resolution from the introduction because it seemed a little elongated upward, up and down vertically in the video when I watched it after I uploaded it. And it seemed like, because I have to show you like a smaller part of my screen, like when I blew it up on my TV, it seemed to get pretty pixely. So I don't know if I fixed that problem or not, but I did make it a little more landscape, and I made it so that I have my computer in like a landscape mode, and I can come over to this side and do work as well as just scrolling down. Although it's very nice to scroll. So back to Ohm's law. We have this circuit here, and well, we have our resistance, and we have our voltage, and we have our source, and our current, and the objective when you're using Ohm's law is to solve for any one of these, given that you have the other two. So what I'm going to do here is, I'm not prepared for this at all. I really should prepare better. But I'm going to come over here. I'm going to change my pen. And I'm going to draw a small circuit. And another way to symbolize a source is to symbolize it like that. And it probably should be flipped around the other way. The long strand being on the bottom and the short strand being on the top, but it doesn't really matter. And I'm going to call that my source, and I'm going to say that source is giving me 15 volts. Alright? So that's how many volts. Voltage is a potential difference. It's hard really to go into what voltage actually is in a short tutorial, but it's just a potential difference that charge wants to move towards or not, depending on if it takes the charge of work to move towards an end of a potential, or if it actually doesn't need work, if that's the work being done to the charge flowing towards a lower potential. So when you see stuff like this, you see your plus sign and you see your minus sign, I like to think of it as gravity. I'm going to come up here to explain potential. It really is gravity. There's a potential difference. If this is the ground, hang on. If this is the ground right here, and you have a ball, the potential energy of that ball is equal to 0. And then if you put that ball and you move it up to height h, this ball now has a potential energy of whatever, x. I think it's just gravity times your height. But the same thing is pretty much like voltage. Just to explain it in a layman's term, you can have say this is your negative terminal right here, okay, and these little red dots here are the charges. Right now they have the same potential as the this thing, whatever it is, a black electrode or something. They have the same potential because they're touching it. I mean, they're not really touching it, but you understand. And let's say that up here we have a positive one. Any electron that is in this positive is going to want to be pulled to the negative because it's at a lower potential. And right now these charges are at a different potential up here than they are down here, and they want to be on the bottom. And I know that sounded really dumb and long and boring, but just deal with it. And so we have our circuit. Moving on with things, we have our circuit, and it's 15 volts, and we have a resistance in this circuit. And the resistor is known as a circuit element, and I'm going to highlight the resistor so everyone knows that this is what a resistor symbol is, and this is what a source symbol is. And I'm going to give the resistor a value of 30 ohms. Alright, that's the sign for ohms. It's a really crappy sign I did, but this is the sign for ohm. I should have mentioned that back before. So Ohm's law has resistance has to do with Ohm's law, and it has a little ohm sign after the resistance of a circuit. And resistance has to do with conductance and just how easy it is for charges to flow through it. So if we want to know, if you guys remember from my last video, I said that current, we're going to follow the conventional current, which means right now current is flowing in this direction away from positive charge. It's a direction of positive charge flow, and it's flowing around and back into the other side, and it just does that all day, and the resistor gets hot or whatever. It doesn't matter. But the current's flowing around, and we need to find what that current is, and we're going to call that current I. We're going to call I1. Alright? Now we know our voltage, and our voltage is equal to 15 volts. And we know our resistor, I'm going to call this R1. And we know that R1 is equal to 30 ohms, which is a relatively low ohm value if you're not familiar with circuits. It is used, but it's not as common as like a 10K, a 10,000 or something. And you have this current, and we don't know what this current is. But we know that Ohm's law is V equals I times R. And if we rearrange this equation a little bit, and we divide the R over to the other side, we're going to get V divided by R is equal to I. And that's the equation we're going to use here. So we have I1 is equal to our V over our R1, which is going to give us I1 is equal to 15 over 30, and 15 over 30 is just 1/2. So our amperage is actually 0.5. Whoops. Our amperage is actually 0.5 amps, which is very high. Which you also see amperage a lot in milliamp notation. Never when it's this high, but if it was in milliamps, it would be 500 milliamps, which is a pretty high current. But then again, we also have a low resistance value and a high voltage. Now let's see what happens. I'm going to keep this value here. I'm going to erase all this, although I could definitely keep some of it. And let's see what happens. I'm going to do all this stuff in a green color. If R is equal to 30,000. No, if R is equal to 10,000, or known as 10K ohms. Now you do the exact same equation, V equal IR, plug in your values, and remember we get I equals V over R. So we're going to get I1 is equal to 15 divided by 10,000. Now you'll notice with this value that we're going to get that it's going to be a lot smaller than our previous value. And that's because our resistance skyrocketed. And if you look at the equation, I'm going to come down here. If you look at the equation, V equals IR. My pen won't let me write. IR. Right? And V is fixed. It can't move. If your resistance goes up, this is gonna denote resistance. If this is your resistance and it goes up, then your amperage that is right here, to make this the same value, has to go down. So that's very trivial. It's an answer that we would expect. So an answer I'm going to go with. And 15 divided by 10,000 should give you 1.5 milliamps. 0.5 milliamps. And I don't know if you know what a milliamp is, but it's basically just this decimal place right there moved over to the right 3 spots. So if I move it back over to right here, if I was to move it back over to right here, I would get 0.0015, and that's the right answer in regular amperage. So it's actually 0.0015 amps when compared to 0.5, which is considerably less. So I'm not entirely sure that I need to go through an example that isn't finding current, but I'm going to anyhow. I won't do both voltage and resistance, but I will do one or the other. And since to find your resistance is almost the same as your the current, is voltage over current, I'm gonna find voltage now, which is very simple and straightforward. So let's say our voltage is unknown. We have 30 ohms of current, and we have 30 ohms of resistance, and we have 5,000 amps. Way high. You really wouldn't see that, but just for, see that the amperage goes up, and you have a 30 ohm source. Let's just see what we get for voltage. It's going to be a really high number. V is equal to I times R. So we have V, which we don't know, which is equal to I, which is 5,000. And that is going to be multiplied by our resistance, which is 30. Whoops. I said 30 and I wrote my parenthesis like a 3. It's weird. Anyhow, so we take 5,000 times 30. And I probably could have just did that in my head, but whatever. And we get 150,000 volts. So if you had a circuit with 5,000 amps and there was only 30 ohms of resistance, which is really nothing, and you will have a voltage source of 150,000 volts. Congratulations, you die. So that's Ohm's law, and I'll be moving on to a little bit harder stuff after these basics. But I hope this was very clear and straightforward. And I hope that, here's my other stuff. Remember that this voltage, current, resistance. I said that resistance is in ohms, so you have an ohm sign. Current is in amps, and a current is a coulomb per second. A coulomb is a unit for charge. So it's a charge per second is an amp. Voltage is just denoted by a big V for voltage, and that is potential difference. Potential difference, and there's a little more to the units and stuff on that you probably wouldn't understand right now anyhow. That I can't really explain easily, but so far that's that. And I think that I did this well. I think that you're gonna have a pretty straightforward answer to what Ohm's law is for whoever may be looking for it. Don't feel belittled if you are. If a lot of people on the comments are saying that it's way too simple to have on here or something like that, just you gotta start from somewhere. So please comment on how I can perform these tutorials better. I'd really appreciate that, and I'll see you next time.